One of the reasons that the given test cases are insufficient is because they do not cover all paths through the method. There are 4 paths through this method, corresponding to each distinct combination of the conditions in the code. If both conditions are true, then 0 is returned. If only one condition is true, then 1 is returned. If only condition 2 is true, then -1 is returned. And if both conditions are false, then 0 is returned. If this is the case, then why don't code coverage tools test for covering all possible paths? Well, because even with if statements, the number of paths can be quite large, and when we add loops to the problem, it quickly becomes intractable. Consider what would happen if we had a program flow that looked like this, where the dark black line is part of a loop that can iterate no more than 20 times. I'm going to show you just one possible path through this code. The path goes through the main loop, and all conditions inside are true. And then the code goes through the loop again and takes a different path this time. And then the code goes through the loop one last time and takes a different path yet again. This entire line that shows the execution going through the loop 3 times and taking 3 different paths, this line represents a single path of execution. So, given that what we just saw is only one path, how many paths exist? The answer is a lot. There are 10 to the 14th possible paths through this code. If we tested one path per millisecond, it would take 3,170 years to cover all the paths. This is why covering all possible paths, which is often referred to as exhaustive testing, is not something that is practical to do. So, if paths are created by conditions, a program with no condition has only one path. Given this fact, you may be able to answer the following question. Is it possible to write tests that cover every path through the code and still have incorrect code? Please pause the video and see if you can answer this question. Ready? Well, you certainly can write tests that cover every path and still have incorrect code. And the next slide gives you an example of this. Here's a method with a single statement. Its specification says that the result returned from this method is equal to the sum of the 2 arguments. Since this method does not have any conditions, it only has one path. Therefore, any test case for this method will cover that path. In this case, we're testing that the sum of 3 and 4 equals 7, which indeed will pass our test case. However, there do exist integers which will not pass this test case. Can you think of what they might be if I give you 5 seconds starting from now? Well, one pair of integers would be maxint and maxint. You will not get a result that is their sum. You will get a valid integer, but it won't be the integer you're looking for. Try it yourself and see. So even so-called exhaustive testing will not cover all possibilities. In fact, the only way we can be sure to cover all possibilities is to test every single combination of input values.